Good afternoon. Today we're going to do a surface area problem in calculus. Here's the surface area formula. When y is your dependent variable and x is your independent variable. It's just the converse when it's the other way around. So here's the surface area formula. And that's y sub x. That's not y times x right here. That's y sub x is in y as a function of x. Okay, so there's our surface area formula. And we're asked to find the area of the surface generated by revolving the curve y equals neg x cubed over 24, bounded from x equals negative square root of 6 to 0, about the x-axis. I've got a lot of other stuff up here too, but that's the problem. Now, the first thing we're going to do, we're going to take this apart piece by piece. Y of x is just this. Our boundary our integral limits are this. dy by dx, we just do the power rule, and we get, after reducing the fraction, you get it was originally neg 3x squared over 24, but that reduces to negative x squared over 8. And you'll need to square that. The negative just squares away. You get x to the 4th over 64. Add 1 to that, so it's 1 plus x to the 4th over 64. And now we're going to put all that inside a square root and integrate over x. So and multiply by 2 pi. Don't forget the 2 pi constant up there. So we got 2 pi times the negative radical 6 to 0 integral. Negative x cubed over 24. 1 plus x to the 4th over 64 dx. Try to ignore what's down there. I'll get to that in a minute. Well, okay, we'll go on. I guess that is next. Now what I'm going to do is, I need to use the chain rule. So what I need is, I need this to be x cubed over 16 and not x cubed over 24. So I'm going to yank out a 2/3. That's just negative 2 pi. I yanked out the negative and put it with the 2 pi. I yank out a 2/3, and that gives me my x cubed over 16. And that allows me to use the chain rule. So with that being said, I can use the chain rule, and now by the chain rule, now first let's just multiply these two things. 2 pi times 2 is 4 pi, so it's neg 4 pi over 3, just after multiplying the numbers. So it's neg 4 pi thirds, and then we integrate from a to b, square root of, now I substitute in u. I let just this part right here, without the radical, just the 1 plus x to the 4th over 64, bare bones, I let that equal u. So what I've got is I replace the square root of this with the square root of u. And then du is just going to be the product of this x cubed over 16 and dx. Now, notice my limits integration would be kind of weird to find, and I'm not even going to fool with them. We're going to go back to x anyway. We're kind of just visiting when it comes to the substitution dummy variable u. So we won't even try to shoot for those. But we are going to integrate and acknowledge that we get negative 4 pi thirds. That's a badly drawn 4. That's a 4 right there. So negative 4 pi thirds times 2/3 times u to the 3/2 ranging from a to b. Now we need to switch back. We ultimately don't want to use a and b. So remember what u is. We're raising u to the 3/2 power. Guys, what I'm learning, when you skip to the bottom part of the board, don't forget you're raising u to the 3/2 power now, not to the 1/2. I forgot that a minute ago, and I spent 30 minutes making a fool of myself. This is a 3/2 power now. So we substitute back in for u, 1 plus x to the 4th over 64 raised to the power of 3/2. This is where I made my mistake earlier. Just be careful about that. Now, if you multiply 4 pi thirds and 2/3, you get 8, with the negative, you get 8 pi over 9. So there's neg 8 pi over 9 times our x expression, 1 plus x4 over 64 to the 3/2. And we're going, now here's our old familiar limits, thankfully. Negative radical 6 to 0. And now we just do the upper limit minus the lower limit. And we're going to end up minusing a negative. We get negative 8 pi over 9. That's going to turn into a plus 8 pi over 9 times 125 over 64. When you plug in your limits, you have to go through some pesky arithmetic. Like if you let x equal radical 6 to the 4th power is 36. 36 over 64 And then that plus 64 over 64 is 100 over 64. And then 100 over, so you got 100 over 64, and then times the square root, 10 over 8, you get the 1,000 over 512, and that reduces to 125 over 64. But that's all the messy work that went into getting this right here. So you get all that, and that's 8 pi over 9 positive. This is negative 8 pi over 9. And then when you add this, you can think of, there's a subliminal 64 over 64 in front of this. So 125 minus 64 let's see, 61. Wait, this is incorrect. This was my incorrect answer from a minute ago. Excuse me. So I got rid of that. So we don't want 2 pi over. That's incorrect. I forgot to erase that from 30 minutes ago. So stop here. We're only right here right now. We're not done. So negative 8 pi over 9 plus this. Now when we perform this, we're going to wind up getting the final answer is going to be 61 pi over 72, I think. Let me see. The final answer is 61 pi over 72. Yeah. Because, let's see, if you, 125 minus 64 is 61, and then that's going to be over, let's see. And then the 64 and 8 are going to cross cancel. Never mind the arithmetic. Let's just not go through that. But you'll end up getting what I got. Your final answer is 61 pi over 72. Let me write that down. So our final answer is 61 pi. Well, I can't find a good marker here. Hold on. I'm all over the place. 61 pi over 72. That's my final answer. And what that is, that's the surface area of the region formed by this graph, bounded on these x limits, and revolved about the x-axis. Now, I didn't really draw the region this time. I don't know if it'd be necessarily prudent for me to try. It'd be something like this. It'd kind of be a slow burn. And then you'd revolve it about the x-axis. You'd kind of get a blowhorn, a 3D blowhorn, but that sort of flattens out for a very long time. You'd get sort of a 3D looking blowhorn right here. And my drawing is horrible, to say the least. It should actually be a symmetric blowhorn, but I didn't really. Let me try to make that more symmetric. Well, even that's not real good. But anyway, that's the main idea. We revolve that about the x-axis, and we get sort of like a blowhorn, maybe. But wait, I'm in the wrong quadrant, though. Well, technically I'm in the wrong quadrant. I need to be over here. But your blowhorn is just going to face so I need to draw this strip. But you're still going to get this blowhorn. It's just going to be oriented like this. It's just going to be turned around. So there's my blowhorn. Sorry about that, guys. Yeah. So this is my graph. Sorry about my wrong quadrant there. I hope this helps, and I'll try to do more videos later. Thanks.